Problem number 12, I'm just looking for some quick trig ratios. If you have them memorized, you can just write the answers down. What would I do if I didn't have them at my fingertips? Well, if I see a quadrantal angle like pi over 2, then I immediately think unit circle. Pi over 2 is up here at 90 degrees. This is the point 0, 1 on the unit circle. And I know the sine value is simply the b coordinate, the second coordinate. In the second example, cosine pi, pi is over here at 180 on the unit circle. This would be the point -1, 0, and cosine returns the a coordinate. So this would be -1 for cosine pi. Let's see, it looks like I've got a couple of pi over 6's. Those are pretty easy to deal with. Pi over 6 is just 30 degrees. You should be able to quickly draw a 30, 60, 90 triangle. They're always labeled exactly the same way. And so the sine ratio, letter F, is opposite over hypotenuse. And the cosine ratio, letter D, is adjacent over hypotenuse. So very quick. And then there's a couple dealing with pi over 4. Pi over 4 is just 45 degrees. Again, it's our other special triangle. We only have two. This one is labeled 1, 1, and square root of 2 every time. The sine ratio is going to be opposite over hypotenuse. I will have to rationalize the denominator there for a final answer of square root of 2 over 2. And then tangent pi over 4, letter E, that's just opposite over adjacent. 1 divided by 1 is just 1. So you can always draw a quick picture, but these are so common that you should try to commit them to memory. So you can always draw a picture, but the more you have memorized, the faster this stuff will go. Problem 13, I'm looking for the exact trig values of angle beta. I've been given a point on the terminal side, and it always seems helpful to drop a perpendicular so that I can actually label the sides of the triangle. This is -√6, 2. I'm going to have to find the hypotenuse, which I can do using the Pythagorean theorem. So if I square this and square the 2 and add those pieces together, I will have the c, or I could have called it the r, squared. Let's see, when you square a square root, you just get the number on the inside. √6 times √6 is just 6. And of course, the negative will square out. So this is simply 6. 2 squared is 4. I'm going to end up here with c squared equals 10. The c, the r, is always positive. And so obviously, I'm just going to end up that c is equal to the square root of 10. Now that I have that, I can fill in the trig ratios by simply using SOHCAHTOA and referring to this reference angle. So sine is opposite over hypotenuse. I'm doing this off to the side because I can see I'm going to have to do some rationalizing here. Let's see, that'll give me 2√10 over 10, but then even there I can cancel some. 2 goes into 10 5 times. So it looks like the final answer here is square root of 10 over 5. I think while I'm on that one, I might as well do cosecant. I just have to reciprocate the sine one, but don't reciprocate the final answer. Reciprocate the one we started with. Then you won't have to do any simplifying. 2 over root 10, well, if I turn that upside down, it just becomes root 10 over 2, and I'm done. Cosine is adjacent over hypotenuse. Got a couple of square roots in this one. I only care about square roots on the bottom as far as the simplifying goes. So I'm going to have to multiply here by root 10 over 10. That's going to give me -√60 over 10. And then I think I can break up the 60. 60 has a 4 that goes into it. So you can split that up as 4 times 15. And then the 4 will come out, which will make -2√15 over 10, and this one just keeps going because now again the 2 and the 10 can simplify. You can't touch the 15 since it's in the radical symbol, and I've got -√15 over 5. Okay, secant is the reciprocal. I don't see any point in turning this one upside down. It'll still be a problem, so I'll just turn upside down that final answer we had. The secant one is going to be -5 over root 15. And then I'll rationalize with root 15 over root 15. That's going to give me -5 root 15 over just 15, I can simplify those front numbers there. 5 goes into 15 3 times. So it looks like negative root 15 over 3 is the final answer here. Tangent beta, that would be opposite over adjacent, so 2 over negative root 6. Got some rationalizing to do here. I can see I've got a negative. It's going to be 2 root 6 over 6. And after I do my canceling, it looks like I'm left with negative root 6 over 3. And cotangent is thankfully easy. Here was the original tangent one. And I can see if I just turn that one upside down, I'll be just fine. Negative root 6 over 2. And so here then are the 6 final simplified answers. For problem 14, we're being asked to take this function and graph it right in the graphing calculator. We're going to go to the y equals area, and then we're going to hit zoom and choice 6. So here's the calculator. I'll go to y equals. I'll type in my function. It was parentheses. Here's the x button right here. X plus 3. Close the parentheses. Use the exponent button to raise it to the 4th power. Let me arrow out of the exponent, and then I had a minus. This is the negative down here. Don't use that. Minus 1. And then if I go to the zoom window, choice 6 is called Z standard, and it just means it's going to show me 10 in every direction. So this is negative 10, positive 10, negative 10, and positive 10. So here's my picture. It's not a parabola. Parabolas have an exponent of 2. It's kind of got a flatter shape here toward the bottom than a parabola does. In any case, we've drawn the picture. Part B says state the domain. Again, domain just means a list of every x you could ever stick into this thing. Well, you can add 3 to anything. You can raise anything to the 4th power. You can always subtract 1. There's no restrictions here. There's no problem you would ever have. So the domain is simply all real numbers. In interval notation, we write negative infinity to infinity. What does that mean on the graph? It just means this graph is going to continue forever in both directions to the left or right. Okay, now we want to find the range of the function, and there is a suggestion here that we go to the graph and use the trace feature on the calculator. The range, let's see, it's definitely not all real numbers because there's a whole bunch of y's down here that are never used. It looks like right here in the middle is the lowest y value, and I mean it kind of looks like it happens at negative 1, but if I want to be sure, I would want to plug in, let's see, x is negative 1, negative 2, negative 3. It happens when x is negative 3. I would want to plug in negative 3 and see what y value comes out. That's where trace comes in. Hit trace, type your x, negative 3, hit enter, and it'll take you to that spot. And sure enough, as I suspected, the y value there is negative 1. What that tells me is the range is clearly negative 1 as the smallest y value, but there's no limit to the biggest. This goes on forever and ever in an upward direction there. So the range would be negative 1 to infinity. Remember, infinity always gets a parentheses. The negative 1 here will have a bracket because it is actually included as part of the range. Letter D, let's reuse that trace button to find h of negative 5 halves. That just means plug in x equals negative 5 halves and see what comes out. So I'll hit trace, negative 5 halves, just use the division button for the fraction, hit enter, and the calculator works in terms of decimals. Here is the y value that comes out. Notice it's actually changed the x value to a decimal as well. I've got negative 0.9375. Finally, in part E, we want to work this out by hand. What if I want to calculate h of negative 5 halves without the calculator and have an answer that's a fraction instead of a decimal? Well, I would just have to replace all of the x's with negative 5 halves. There's only one x over here on the right. It happens right at the front. Negative 5 halves plus 3, then to the 4th power, and minus 1. To add negative 5 halves and 3, maybe I should go off on the side here. I'd have to write 3 as 3 over 1. I'd have to get a common denominator. This is going to end up being negative 5 halves plus 6 halves, Well, negative 5 plus 6 is just 1. And so that comes out to be 1/2. That parentheses comes out to be 1/2. Now I have 1/2 to the 4th power minus 1. 1/2 to the 4th power, that just means 1/2 times 1/2 times 1/2 times 1/2. You can write it out if you want to, and that should make you realize all you have to do is multiply across. You're just going to get a bunch of 1s on the top, and 2 times 2 is 4, times 2 is 8, times another 2 is 16. So I get 1/16. The last thing I have to do is subtract 1. Well, again, I'll just write that as 1 over 1. I'll get my common denominator of 16. I'm going to end up here with 1/16 minus 16/16, and that comes out to be negative 15/16. So there would be the exact fractional by hand answer to the problem, negative 15/16. If you wanted to verify for yourself that these two answers are the same, you could just go to the calculator and type in negative 15/16. Let me quit out of this mode. Negative 15 divided by 16. Hit enter, and of course I get negative 0.9375.